Good morning, students. Welcome back to yet another class of this software engineering. Just recall what we have discussed in the last class about this software engineering challenges, problems with software engineering. Okay. In the last class, we discussed about the difference between a program and software. Then, what is the problem with software engineering? That is, there are at least four problems. The expectation from industrial strength software, and that we have discussed in the last class. And we are going to discuss why the software is expensive and what are the reasons. Though it doesn't have raw materials like any other engineering, still it is expensive. Why it is so? Then why it could be late and unreliable, and why you have to maintain and rework. Those things we will discuss in today's class. Okay. What are the expectations from industrial strength software? That is ordinary software developed by software development companies. Quality is a main issue because the developer is one, the user is another one. The user comes for a software for his business to the developer. Developer develops the software for the user needs. That means the quality should be of high standard so that the user is completely satisfied. To maintain that quality, several testings has to be done. When you increase the number of testing, it will increase the cost. Okay, so cost to reduce the cost, you cannot compromise on the quality. Okay, so cost also has to be curtailed. It has to be kept to minimum, but still the high quality has to be maintained. And also, to get the better quality, the work has to be done in a phased manner. So the schedule of development has to be developed into various phases, and each phase has to be developed separately, and on completion of one phase, you will go to the next phase, and like that. And also, in the industrial strength software, you should ensure portability, and it should allow some kind of tolerance to the errors, and you should be able to have a backup and a recovery of the software. These are all expectations from industrial strength software. This we have to do. And next issue with the software is expensive. Why it is expensive? Why the software is expensive? You should know that it is a labor-intensive work. It's not an ordinary task. It's a labor-intensive work of highly skilled professionals. Okay, they don't develop the software over a period of week. They develop it over a period of 6 months or 1 year. Many a time, the size of the development team could be from 50 to 100 or even more. They have to work right from the scratch of the problem, from problem analysis, getting the user requirements, then ensuring that the developer team understood the problem very clearly, then they should develop the requirement specification document, and they should validate that requirement specification document. Then the team should go for architecture design of that SRS document. From there, they will go for coding, designing, and they will go for testing one by one. So right from the very initial stage till to the delivery stage, it's a great deal of work by a skilled professional. So it is labor intensive. Okay, how is the size of that software is measured? Okay, in software engineering, the size of the software is measured in terms of lines of coding. LOC. LOC means lines of coding. How many lines of coding that particular software requires. And if the size is measured on lines of coding, how the cost is measured? Cost is measured as person months of effort spent in development. It is not the cost for per day work or per month work or not like that. It is cost is measured based on the person months of effort spent on the software. Okay. As an example, you look at this case. Suppose software needs 500 lines of coding for person month. Okay, then if the cost to the company is $10,000 means per person month, then 10,000 by 500 gives you each line of cost coding will cost you $20. $20. That is, each line of delivered code is $20. That is quite expensive. Okay. For example, consider an application that is a software takes some 20,000 lines of coding, and cost for 100,000 of coding is $1 million. Okay, then that means the cost will come around $10,000 to 20,000 on hardware alone. Okay, so hardware cost in an IT solution is very small. Okay, so the hardware cost for this for executing this one comes to around some $10,000 to $20,000 only, whereas the software cost will come to 100,000 to $1 million. $1 million. That is much higher comparing to the hardware cost. So it is right opposite to the other engineering disciplines. So here the hardware cost is in software engineering is less comparing to the software cost. In the early 90s, the hardware cost is more, software cost is less, because the number of areas where the softwares were developed is less, and even for a smaller area of applications, the hardware costed more. Okay, whereas when you go further in the next 3 decades, maybe in the 80s decades, the scenario has reversed. The hardware cost is just 20% only, whereas the software cost has risen up to 80%. Okay, so the cost per development of a line is cost in the software development. Okay, so it is a labor intensive work. It is very expensive, both in terms of cost and as well as in terms of time. So that is the case Only when the software goes in the right direction and it is successfully completed. If something happens during the development, during the development, then if the problem is not understood and the development is going on in the wrong direction means, then the expense is even more bigger, it is very damaging for the developer. Next, the software development is late and unreliable. See, when a customer comes to the company for software development, there will be agreement between the user and the developer. Just like a builder builds a house for a particular person, maybe some 6 months, okay, from the groundbreaking stage till to the delivery of the keys of the completed house, it is some 6 months. There is agreement between a building contractor, maybe a builder, and a person who is financing for whom the building is constructed. Just like that, even in the software development also, a customer comes to a company for software development of his business activity means, then there will be a agreement, okay, from this date you should take this much of date and you should complete this work and deliver the complete project on this or such and such date. That is the agreement. But many a time what happens is the agreement could not be fulfilled. The development might be delayed for several reasons. Some of the reasons might be from the developer side. Some of the reasons could be from the customer side, user side. How it is user side? Initially, the user or customer comes with a set of requirements. Then all of a sudden, he comes up with a new set of requirements, some additional set of requirements. But what the developer has planned is for the original given set of requirements. When the new collection of requirements are coming up means, then everything has to be, the logic has to be, the design has to be, the architecture has to be redefined. That takes some time. Okay, these are one of the reason from the customer side. Okay, they change their needs. Then, for some reason, the government policies might change the development work. Okay, the government might impose certain restrictions, certain work, some tax section and everything. And the developer has to complete that project within that particular cost, which was agreed upon earlier between the developer and the customer. And due to the change in policy of the government, the project could not be, the software could not be developed within that particular cost. So the developer has to readjust his constraints. Okay, so that will cost some time. Then most of the reasons are from the developer side in this area is the particular team that is developing the particular software. Some team members might resign their job and move to some other project or some other company. In that case, the new member to the team has to be brought in. He has to be trained. First of all, he should understand the problem and he should get accustomed with the new team. And these are several reasons why the delivery time gets delayed. Okay, even the development time gets elongated and the delivery time gets delayed. Okay. See, out of 100 softwares, you should know that some 20 to 25% of the softwares are not at all completed. There are several reasons behind not completion of that particular software. Several reasons. Okay, we call such softwares as runaway softwares, runaway projects or runaway softwares. So what is a runaway software? A software whose deadline has exceeded, whose cost of production has exceeded the initial expectation and hence has to be dropped. They are called as runaway projects. That is projects that has gone out of hands of the development of the company. That is called runaway projects. That is exceeded cost-wise, exceeded time-wise, exceeded labor-wise. Such a projects are called as runaway projects. Out of 100 projects, some 20 to 25% of the software projects might end up as runaway projects. One thing you should know that the failure of the software is different from failure of the product in other engineering disciplines. Okay. See, in other engineering disciplines like mechanical engineering or electrical engineering, for example, civil engineering, we have a visual object. Mechanical engineering, let us take, they produce one four-stroke motor engine, okay, for a two-wheeler. See, there is a wear and tear on that motor. The motor might work for some 10 years or 15 years, and due to wear and tear, it will gradually come down and it will stop execution at one stage. That is not the case with the softwares. There is no such thing called as wear and tear of softwares. They are all they are not physical objects like an engine or a building. Okay, there is no such wear and tear for the softwares. But the issue here, main issue here is, if there is a problem with a product in a mechanical engineering or in civil engineering, then the effect of the problem is immediately sensed. Okay, even during the trial run, the developers, the manufacturers can sense something wrong with that error, something with the product being manufactured, and can rectify the product. That is not the case with the software engineering. Problems might creep in at any stage of the software development. It can creep in from the very beginning stage of problem analysis. Then it will keep quiet with that wrong information, with that bug, with that error only the software gets developed. Then the effect of that software error will be realized only on completion of that software. Till then, 90% of the errors are not at all picked up. Only when the software is completed and the trial run is being run, then the errors are picked up. By then, the enough damage has been done by the bug or error in the software. Cost of development, cost of time, everything has been wasted. They have to correct that error. Many a time correcting the error will cost even more expensive. So the failures in the software engineering, softwares are not at all like failures in other engineering disciplines. Okay, that should be that you should know. Okay, there is a great deal of difference between software engineering and other physical engineerings like mechanical engineering or electrical engineering or civil engineering and others. Okay. Then unreliability. Many a time the software does not do what it should do, or even if it does something, it does something that it should not do. It should not do. That is the thing. The software becomes unreliable due to very many reasons. Many reasons. The foremost problem of software becoming unreliable is the poor communication between the customer, that is the user, and the developer. When the customer comes with some request, the developer, otherwise the problem analyst, should understand the problem exactly. He should know what are the requirements of the customer. He should know what are the problems involved. Okay. If there is a error in understanding the user's requirement, expectation of the user's requirement, the software becomes unreliable because the problem analyst will prepare a requirement specification document with the wrong expectation from the customer. Then ultimately the software will become unreliable. That is one of the reasons. So that is why the software can become late and unreliable. Next problem with the software development is maintenance and reworking. Maintenance and reworking. Just like every other engineering product, your software too should be maintained well. Okay, even after the delivery to the customer has to maintain it. From the customer side, they should know, they should have a complete understanding of the existing software to maintain it. What are the various modules in it? What is the role of each and every module? What is the input to this particular module X? And what is the output to the particular module X? The output of the module X goes to which module? Or does it go to another module, or it comes out as an output? He should have a complete understanding of the software to maintain it. Then some changes has to be made in the minor changes has to be made in the delivered software means. Then what will be the effect of that change after performing that correction in the software? Okay, they should have a clear idea the effects of making some small corrections in the delivered product. Okay, when you do such a change, you have to do changes both in the code and the document. Usually the customer or from the customer side, these changes will not be done. The changes will be done by the developer. Okay, why these things comes under maintenance fee? It's not major radical changes. There are rather some minor changes. Maybe the software may have to be moved from one system to another system. From one system to another to make it functioning well in other systems, some minor changes has to be done. It is not the logic that is being changed, rather the software is corrected to adjust to the new environment in which it is going to be working. And also making some correction. After making some correction, maintenance involves testing the new parts which has been changed and retesting old parts that were not changed. One thing you should know that Not all the modules in the software are completely independent of each other, mutually exclusive of each other. No, they are all related to each other. So making some corrections in one module, you should know, does it has any effect on the other modules? And testing the new module and testing the old module which is not corrected, these things has to be done as part of maintenance work. Rework. This I told you already. The rework has to be done not because of the poor workmanship from the developer, but due to extra additional needs from the customer. Initially, when the customer comes up with some 25 requirements, after some time, he comes up with another extra 5 requirements, maybe coming to total of 30 requirements. Before he brings in another 5 requirements, part of the work has been completed for the 25 requirements. When these additional 5 requirements are coming up means, then the software may have to be reworked. Many changes has to be done. So rework is due to a change in requirements from the customer side, okay, or it could be due to poor understanding of the requirements, okay, poor explanation of the requirements. So these are the problems that are associated with software engineering. First, the expectation of the software, then it is expensive, then it is late and unreliable, then it has to be maintained, and rework may have to be performed depending on the situation. Okay, by this time you got some idea about some issues with the software engineering. Okay, in spite of all these expectations, all these problems, still the customer is willing to go for automation of his business activity. Still, he wants to build a software for his business activity. So when he goes to a developer for developing a software, what are the challenges both the customer and the developer will have to face? Some of the challenges are scale, the size of that software that is going to be developed, quality and productivity, expected level of quality, and consistency and repeatability. What the methods used by the developer for that problem should be the same method can be adapted to some other problem of same kind, and the developer has to make some provisions for change. These are all some of the challenges the software developer will face. These are going to be our discussion in the coming classes. Scale, quality and productivity, consistency and repeatability, change. Okay, we shall see those topics in the coming classes. Okay.